don't you get out your journals and we'll take a quick review about the calendar grid that we were using before we left for this extended leave. And we're going to review it so that you can continue it on your own. So just to remind you, our calendar grid started off with a pink rectangle whose vertical dimension was 76 and whose horizontal dimension was 264. And we don't know exactly what units they're using, so we're calling them units. They asked us to find the area. And so we used the expression 76 times 264. And after many different estimates, we came up with using the estimate of 250 times 80 because we thought that 25 times 8 was an easy fact. It gave us 200. And then we just had to add on the 2 extra place values. When we figured them out, when we figured the actual area out, some of you used the standard algorithm, some of you used the area model, some of you used partial products, but we ended up getting 20,064 square units for our first calendar day. And then we went to our second one, and if you open your journals, I'm sure you'll find this there. We went to our second day. And it also was a pink rectangle, but its dimensions, its vertical dimension was 76 units. Its horizontal dimension was 26 and 4/10 units. So one of the things that we noticed right away is that all of the digits were the same as day one, but this factor was 1 place value less. So we said, okay, well, let's use our same numbers to estimate. Instead of 250, we'll make this 25. We'll keep this at 80. Again, 25 times 8 is 200, but now we only have to add 1 place value. So not only is our expression 1 place value less, but our estimate has now also 1 place value less. This was 20,000 and now it's 2,000. And then again, when you did the actual multiplication, we realized that the answer, the product, had to be 1 place value less than this. And so the actual answer here was 20,064. Because 1 factor is 1 place value less, we know the product will be 1 place value less, and that's 2006 and 4/10. And we also noticed that we could, knowing that all the digits were going to be the same, we could use our estimate to decide where to put that place value. If our estimate is 2,000, then it makes sense to put the decimal point here so that we would have 2006 and 4/10. We did the same thing with day 3, 4, and 5. Let's just talk about them quickly. Here's day 3. Also a pink rectangle. Our vertical dimension is 7 and 6/10, 1 place value less than this. 1 place value less than the first expression, and we're going to multiply that times 264, which is 1 place value greater than this and the same as this. So if we're comparing the two of them, let's compare the original expression to this expression. We can see that 7 and 6/10 is 1 place value less, and this is the same. And so we can now say, if we look at our actual area, that this is going to be 1 place value less than this. So if that's the truth, and again, we used 250 for our estimate times 8, and we got our answer of 2,000 because 25 times 8 equals 200, and we have to include the extra place value. if we know that all the digits are going to be the same, we can just write out and then decide where our decimal point is going to be. If we use our estimate again of 2,000, the only place it makes sense is right here, because 2006 is very close to 2000. If we had put our decimal point here, that would be 2 and 64 10,000ths, and that's nowhere near 2,000. If we had put it here, it would be 20 and 64 hundredths. Again, nowhere near 2,000. So we can always use our estimate to determine where it is, or we can go back to our original equation and say, well, this factor is one place value less than this, and this is the same, so our product needs to be one place value less than our original product. So again, in our observations, we can put one place value less. And then we look at our next one, which is also a pink rectangle, and this time it had to be blown up because it was so small. And the vertical dimension of this is 7 6/10, and the horizontal dimension is 2 64 hundredths. So when we're looking at this, we can see, just like when we were playing the game, that 7 6/10 actually rounds up to 8. 2 64 hundredths would round up to 3, and 8 times 3 is 24. We could have estimated it many different ways, but this is probably the fastest way. So again, we notice that all of our digits are the same. They're just different by place value. But because we're multiplying all the same digits, we're going to have all the same digits in our product. So we can just write all those digits down and then see where our decimal point should go. If we use our estimate, where would we put the decimal point? Well, if we put it here, 2 isn't really that close to 24. 20 and 64 hundredths is pretty close to 24. 200 is too far away. 2006 and 4/10 is too far away. So the only place that it really makes sense is right here. 20 and 64 hundredths. We can also look at it if we compare it to our original. 7 and 6/10 is one place value less as a factor, and 264 versus 2 and 64 hundredths, this one is 2 place values less. So if both of our factors together have 3 place values less than the original, we can take the original number and count over 3 place values less. And again, we get 20 and 64 hundredths. And so we used 3 place values less than our original product. And finally, we're not looking at rectangles now, we're just looking at a problem. And the problem they've given us is all pink. So I think I'm starting to see a pattern there. It's all pink, and the factors are 2 and 64 hundredths times 0 and 76 hundredths. So what have they done? They've showed us that because of the commutative property, we can switch those around. We don't have to have them in the same order, but as long as they have the same digits, the products are going to be similar. So if we want to estimate this, We can make this into the 3 because 6/10 is greater than 5/10, so we round it up to 3. And 0 and 76/100 is close to 1, and 3 times 1 is 3. Now, hopefully you can tell me that because these have all the same digits, only the place values are different, that you know what digits are going to be in the answer. And that's right, we have 2, 0, 0, 6, 4. Again, we can find out where to put our decimal point by comparing it to our estimate. Our estimate's 3, so you guessed it. We're going to put the decimal point right after the 2. But if we want to adjust by place values, how different is this from this? Well, let's start with the 76. 0 and 76/100 is 2 place values less. And if we look at 264 and 2 and 64/100, that's 2 more place values less. So if we add them together, 2 place values less for this factor, 2 place values less for this factor, we get 4 place values less, and we adjust it by moving it 4 place values, to the left. So our final answer is 4 place values less than the original product. I'm hoping that you remembered all that, and we're going to go on to week 2. Maybe I'll move this over here so we can refer to it if we have to. I don't think that's going to work. Do we have another piece of tape? Oh, thank you. All right, and let's look at this. Day 6, again, they'll be asking us to find the area of a rectangle by multiplying its length times its width. But this time, it was yellow. It's a yellow rectangle. And its vertical dimension is 101 units, and its horizontal dimension is 284 units. We discussed it in class, if you remember, and we decided that the easiest estimate would be to change this to 100. Anything times 100 goes up 2 place values, and so we got, for our estimate, 28,400. Now, lots of you found the actual answer many different ways. So some of you said, well, if I know what 100 times 284 is, I can just add another group of 284 to this and get 28,684. And that's the correct answer. Others tried the standard algorithm, and still others used the area model. So we'll show you that again. The area model allows you to break down the factor by all of its place values. 284 becomes 200, 80, and 4. 101 becomes 101, and then you multiply them together. So you're finding the area of each one of these sections. So 200 times 100, 2 times 1 is 2. And then we have 1, 2, 3, 4 place values to increase it. And then we put in our comma. 100 times 80, 1 times 80 is 80. We increase it by 2 more place values, we get 8,000. And 100 times 4 is 400. Now we do the same thing with our 1. We broke this place value out, 101. So 1 times 200 is 200, 1 times 80 is 80, and 1 times 4 is 4. At this point, you can add these up any way you want. I like to go across for this one. So I would have 28,400, and I would add to that 284. And again, for our final product, our actual area, we would get 28,684 square units. And there's no observation right now because we don't have to adjust any place values. Although I will say that a good observation, again, that several of you noticed was that if we took our estimate, which ended up being our first partial product, and we added one more group of 284, we get our answer. All right, let's look at day 7. Day 7 is again a rectangle. It's yellow. Its vertical dimension is 101. Its horizontal dimension is 28 4/10. So, our expression is 101 times 28 4/10. And so what do you want to use as a estimate? Well, let's use 28 times 100, and we get 28, and 2 place values, 2,800. Now we could have used 28.4, and then our estimates would look more similar, but it's not necessary. We don't have to include that 4/10 in our estimate. We do have to include it in our actual. And so, again, now we're in our actual answer. We have 28 4/10, and we're going to multiply that by 101. And remember, in multiplication, you do not have to line up the decimal points. You do not have to line up the place values when you're multiplying, because every place value gets multiplied by every place value. And what we learned here is, if we have all the same digits, there will be all the same digits in our product, in our final product. So we're just going to write those in. 28684. And then we're going to decide where our decimal point goes. So we can use our estimate, and we know that it's going to be somewhere around 2,800. And in that case, it only makes sense for the decimal point to go there. And then we add in our label of square units. However, if we want to use our original expression to determine what the answer would be for this, we know that this is the same factor, and this is just one place value less. So we know that our product has to be adjusted by one place value. And so that would be like if the decimal point was here, because it's a whole number, we would move it in between the 8 and 4. So we've adjusted it one place value from our original expression. Okay, I think we did one more in class, and I will send you these sheets so that you can review them at home and try the ones that are coming up in the coming weeks. And again, we have, and I'm hoping you're seeing the pattern here, again, we have a rectangle that they're asking us to find the area for, and the vertical dimension is 10, and you guessed it, 1/10, times 284. Okay, If we want to figure out what our estimate is, we can keep our 284 because we have an easy thing to multiply it by. We're just going to make this 10. When we multiply any number by 10, it increases by one place value, and since 284 is a whole number, we increase the place value by sticking that 0 on the end. And so we have 2,840. That's our estimate. Our actual is 284 times 10 and 1/10. So again, if we have all the same digits, we will have all the same digits in the actual answer. So we can write down those digits in order and then decide where our decimal point would go. If we use our estimate, it's very easy to figure out where that decimal point goes. And if we compare it to our original expression, we see that this factor and this factor are the same, except this is one place value less. These factors are the same. So since the entire equation is just one place value less, our product is going to be one place value less. Okay? What I'm going to ask you to do is do the next two on your own. And you can put it on the sheet that I'm sending you if your parents were able to download and print it. And if not, just do it on a separate sheet of paper. And you can email me what you think the answers will be. So number 9, again, a yellow rectangle. And the factors of this are, the vertical dimension is again 10 and 1/10. And the horizontal dimension is 2 and 84/100ths. So I'm looking for an estimate, an actual, and how many place values you needed to adjust your final answer. And then if you're following the pattern, you would realize that day 10 would be yellow, and they wouldn't be asking you for area. Now they're going to just be giving you a simple problem, and again, they switched the factors. They're using that commutative property to say it doesn't matter the order of the factors, you can switch them up and the answer will still stay the same. And this one is 2 and 84/100ths times 1 and 1/100th. So if you can just fill in the chart for these two, email me your answers and we'll see how you're doing. Thanks so much. Have fun.